Morning, ladies and gentlemen. This is week 3, Inequalities. Okay, so let's take a look at number 1. It says the inequality 7 minus 2/3 x is less than x minus 8 is equivalent to. Okay, so equivalent to, right, all they want you to do is, if you look in all 4 of these cases, what it look like they solved for? They solved for x. Okay, so in each case here, we're going to have to try to, or in this problem here, we're going to have to solve for x. That's what it means by equivalent to. Okay? So, where do we start? Well, I'm going to bring this 8 over. Okay? So negative 2/3 x plus 15 is less than x. I'm going to add 2/3 x, okay, to both sides. Now what stinks about this problem is we got x plus 2/3 x, okay? So these are like terms, okay? As you can see, it's got an x off to the side here. But the problem is when we go to add these together, okay, we got to take into account there's a 1 in front of that x, or a 1 over 1, okay? So when we go to add this together, all right, so it's going to be 1 over 1x plus 2/3 x, and when we add those two fractions, okay, I'm just going to do that off to the side, okay? We must multiply the top and the bottom by 3, okay? Because when you add fractions, you got to have a common denominator, which is that number in the bottom, okay? So now when we set this up, we got 2 plus 3, which is 5, and then you bring the 3 over, okay? We don't add 3s, we just bring that denominator over. So, our answer, it's not really our answer, is 15 is less than or equal to 5/3 x, okay? So, I'm running out of space here. Let me see if I can shrink this up. Okay, so now, here's our equation right here. Let me move this out of the way as well. Oops, I'll just give a little circle around there. Okay, so we're right over here. This is where we're at. So this is our last little bit. So in order to solve for x, okay, we got this 15 is less than 5/3 x. Okay, so in order to get rid of this 5/3, we're going to use the multiplicative reciprocal. Okay, so what the multiplicative reciprocal is it's the reciprocal of 5/3. So you literally just flip the fraction, and so you multiply each side by 3 over 5. And then what happens on the right? Your 3's and your 5's cancel. What happens on the left? You get 15 times 3, which is 45, over 5. And 45 divided by 5 is 9. Okay, now be careful. Our variable's on the right. We need to convert it to the left. Okay, so when you put it on the left, make sure you bring that sign with it. Phew! Excuse me. Woo! All right. So there's our answer. X is greater than 9. And do we see that over to the left here? We sure do. Okay? So that's what we were looking for. That's number 1. Number 2. Right? Connor wants to attend the town carnival. The price of admission to the carnival is $4.50, and each ride costs an additional 79 cents. If he can spend at most $16 at the carnival, which inequality can be used to solve for R, the number of rides Connor can go on, and what is the maximum number of rides he can go on. Woo! Okay, so we got a couple answers to go through here. Let me change up my color here. All right, so Connor wants to attend the carnival, right? So when he shows up, all right, he wants to get inside. Okay, the carnival cost $4.50. Okay, that is our cost. All right, so before he even rides anything, he has to pay $4.50. Okay, and then plus each ride costs an additional 79 cents. Okay, so it's 79 cents times each ride. Okay, so each ride is going to cost 79 cents. Now, the ride is kind of like our input, right? Right? And in this case, solve for R. R represents the ride. So I'm just going to shorten this up here. I'm going to make this an R. Okay? So it's 79 cents per ride. All right? So, if we look over to the left, we see something that looks very similar to this, right? $4.50 plus 79 cents per ride. All right? So, if you look, number 1 and number 2 can get crossed right out. Now, if he can spend at most $16 at the carnival, which inequality can be used to solve for R. All right, so we don't have to solve for R. Oh, actually, we do, because we need to find the number of rides. My bad. Okay, but in order to solve for R, we've got to make sure we got the right equation. Okay, so let's look at this word right here. Since we're talking about inequalities, we're looking at this word at most. Okay, when we talk about at most, all right, when I'm handing out pieces of candy, all right, I think I've used this example more than once, okay, all right, you can take at most 3 pieces. So that means you can take 1, you can take 2, or you can take 3, okay, but you can't take more than 3. So when you see at most, okay, I have at most $10 in my pocket, that means I have at most $10, all right, so you can only spend up to that much. I might have less than $10 in my pocket, but at most I have up to 10. Okay, so when we're saying at most means less than or equal to. And what are we at mosting? What's the most we can spend? $16. Okay? All right. And now we solve for R. So in order to do that, subtract 450 from each side. Okay. Divide both sides by 79 cents. And you get R is less than, oh, not 12.50, I'm sorry, that's supposed to be 11.50. Yeah, yo. There we go. Don't forget to divide by 0.79. Okay. And you should get 14.556. Okay? Now, you do see a couple answers there, all right? And they both look very similar. So now it's up to us to decide which one of these is right. So, take a look at this number here. Right? R is less than 14.556. So, that means, okay, is that we didn't quite reach 15 rides, right? Right? We're less than 14.556. We don't have enough money for 15 rides, all right? That's basically what this is saying here. Okay, we have at most 14.556. All right, and you can't take 0.556 of a ride, so therefore 4 is out. 3 is your answer. Okay? That's number 2. Number 3. Here the graph of an inequality shown below. All right, so write the inequality represented by the graph. On the set of axes, graph the inequality x plus 2y is less than 4. And the two inequalities graphed on the set of axes form a system. Oscar thinks that the point 2, 1 is in the solution, yada, yada. Okay, so we'll get to that part at the end. All right, we need to read through the whole instruction. So let's just start with number 1, or letter A. Okay, so write the inequality represented by the graph. Okay, so this is linear, right, which is nice. Okay, I see a y-intercept. Okay, which our y-intercept is 0, -3. Right? And then I'm going to measure its slope. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so its slope is 2 over 1, or just 2. Okay, so don't forget, our slope is just that rise over run. Okay, so write the inequality represented by the graph above here. Okay, so we have our slope, we have our y-intercept. So let's just write this equation first in y equals mx plus b form. Okay, once we have it in that form, then we can switch it over to an inequality. But first we need to have it written as an equation first. Okay, so y equals 2x minus 3. Okay, so there is our equation, but we need to write an inequality. All right, so let's take a look. Right, up here, what side of the line is being shaded? Above the line or below the line? Okay, so in this case it's above the line. And also, if you notice, it is a solid line, so y is going to be greater than or equal to 2x minus 3. Okay? So there is our equation. Or inequality, sorry. Derived from our equation. All right? We had to start with an equation. So, that is letter A. Letter B says, right, on the same set of axes, graph the inequality x plus 2y is less than 4. Okay, so in order to graph this, we need to get it into that, again, that y equals mx plus b form. So I subtract x. So I get 2y is less than negative x plus 4. Divide by 2. Make sure you divide both pieces by 2. And you should be left with y. I'm just going to write it over here, underneath here. Okay, so b is y is less than negative 1/2 x plus 2. Okay? Don't forget that negative x over 2, okay, is just equal to negative 1x over 2, which is just equal to a negative 1/2 x. Okay, don't forget that you can kind of move that fraction in and out of your slope there in the front. Okay, so the two inequalities graphed on the set of axes form a system. Oh, I'm sorry, did I graph it? Nope, I did not. All right, let's graph this bad boy. So y is, let's start with graphing the equation. All right, so our intercept is 2. So let me get a different color here. Then our slope is a negative 1 over 2. Negative 1 over 2. Negative 1 over 2. Okay? Now, if you take a look, okay, what kind of symbol do we have here? This is just a less than symbol, okay? Which means when we go to draw this line, we don't want it to be a solid line. We want it to be dotted. Okay? Also, I got to make sure I label these inequalities. So this one is A, and this one is B. Now, it also says that we need to shade. All right, so y is less than this line, so you go to your line. Okay, this would be above the line. This would be below the line. So we're going to shade below. Okay, and our solution is right over in this section here. Okay, and now the question's asking, all right, this is letter C. All right, Oscar thinks that the point 2, 1 is the solution. Determine and state whether you agree with Oscar. Explain your reasoning. Okay, so let's take a look at 2, 1. 2, 1 is right here. Okay, now if we just had equation A graphed, okay, and they were asking if 2, 1 was a solution, we would say yes. But if you notice, okay, 2, 1 is also pretty significant because this is actually where these two lines intersect. And unfortunately, for letter B, because it is a dotted line, any point that falls on that dotted line is not a solution to the set. Okay, so therefore, okay, 2, 1 is, well, let me get a different pen here. 2, 1 is not a solution because it falls on the dotted line. Okay? So 2, 1 is not a solution because it falls on the dotted line. So that is number 3. Okay, so we're going to do 4, 5, and 6, and we'll pause the video so it doesn't take me forever to download. So this will be most of the week here, and then I'll finish up the rest in the next video. Okay, so the next 3 are literally just solving the inequality. Okay, so that's why I'm going to end on these 3 notes, because the next one will start with talking about strawberries. Okay, so we're kind of taking a little break from the word problem. So anyway, so here is okay, and we are solving for x. All right, now what sucks about this one is, yes, the fractions. Okay, but what's positive about this is, if you notice, hey, look at that, what do we see there? Common denominators. All right, so what's cool about this one is that we don't have to worry about converting fractions into common, changing fractions so that they have common denominators. Okay, we don't have to worry about that. All we got to do is get the x's on one side, get the constants on the other, and then go from there. Okay, all right, so easy enough. So I'm gonna bring this over, right? Because I try to avoid positives or negatives as much as I can. Okay, so when you add 1/3 to both sides, you're going to get 3/5 x plus 2/3, right? Because we've got a common denominator, so we just add the 1 and the 1, is less than 4/5 x. Okay, now our next step is you're going to bring 3/5 x over to the other side. So now we have 2/3 is less than, and then 4/5 minus 3/5 will give us 1/5 x. All right, because again we got common denominators. So all we got to do is just subtract the top. And then multiply both sides by 5 over 1. All right, this is the multiplicative reciprocal. And you're going to get 10 thirds is less than x. And we're just going to flip that around so we can read it correctly. X is greater than 10 thirds. And that's how you want to read the solution here, guys. All right? Because that means a lot more to what we're looking at up here. What solutions do we have for x? All right, any x that is greater than 10 thirds will give you a true statement for number 4. So that's what we're looking for when we're solving for x. We're looking for what value can we put in for x to keep this inequality true. All right, I actually just got time for one more, and then I have a Zoom meeting. So this will be the last problem for this this section here. Okay, so the solution to 4p plus 2 less than 2 times p plus 5 is. So what we're looking for is basically what we did in the last problem. All right, solve for p. All right, so in order to do that, I'm going to distribute that 2 in. So I'm going to have 4p plus 2 is less than 2p plus 10. All right, now we're just going to combine like terms. So minus 2p, you get 2p plus 2 is less than 10. Subtract 2. Oh, whoa. Wrong 2. Ayo. All right. Subtract 2. All right, so you get 2p is less than 8. Divide by 2. P is less than 4. Excuse me. Okay. And so, those are your answers for 1 through 5.